Good afternoon, everyone.
Afternoon.
Afternoon, sir.
All right. So last week I remember we start doing on the network design, right? Did we start on network design or did we finish network design? I can't recall now. All right. So because week 12 network design, network troubleshooting, and then network virtualization, network automation, right? So I know we did network design. I think network troubleshooting. Right?
Whatever your
Not check, network troubleshooting. I think not check. So, but network design, did we cover everything, or do we get to router hardware already, or is it scalable? Do you guys remember?
I don't recall, sir.
Sorry,
Unknown.
network design. Did we finish network design, Noel? Halfway, I think yes. Thank you, Farah. So I believe I finished the first part lah. So this scalable, I think scalability. Yeah, I think scalability also we've covered. Right, so that means we are at switch hardware. Right, so we'll start with switch hardware this week. Right, so you can see that for our lecture, network design, network troubleshooting, and then week 13 and 14 is network virtualization and automation. So we'll see if we finish the network design, we go on to network troubleshooting, see whether we can start on network virtualization, but I don't believe so. So that means network virtualization and network automation we'll try to fit it into week 14. All right, see how it goes. All right, so let me share my screen. All right, so switch hardware, I'm going to look at some of the models now. I think we'll go very quickly on this one, just to identify some of the switches, switch platform that is available with Cisco, right? So basically, we have from the Cisco brand, yeah, there's a lot of models basically, all right? So you have to choose the correct model for the correct usage, right? So example here, you can see that's provided here is actually Cisco 3850 series. That means a series model. That means they keep upgrading it, probably upgrading the hardware, right? So but the longevity of a Cisco switch is quite good lah. That means because apart from increasing or changing certain things, normally the model is quite stable, right? You hardly ever find any faulty model, right? So you can see here that it says here example usage campus LAN switches, and you can see the number of ports for this switch. That means this switch is highly capable to, to cater for a lot of users. So in campus, that means a lot of workstation or hosts it's available, including labs. Yeah. So you can see there's so many ports here. Each of these ports you can imagine leads to a host. All right. And to provide even more ports, you can stack the switches together, right? So extended switch or standard star topology. Okay, simply the physical way you store is actually as a stack lah. You stack one switch on top of another just to provide extra ports, right? So you can see, of course, this Cisco switch, as any other switch, Cisco switch have the full iOS capability, right? All right, so there's a different type again, Cisco Meraki here and Cisco Nexus. So Cisco Meraki is cloud managed access switches, right? And this one is something a little bit special. Just now it's physical stacking, right? You can see the switch being stacked, but this one is a virtual stacking of switches. That means even remotely, the switch can be thought of, can be stacked even though they are remotely available. So you can virtually stack those switch together. To stack here simply means one switch connect to another switch. So virtual stacking simply means using the network access, right, to make as if these two switches are stacked together, right? So these are cloud managed access switch. They are used to, Cisco Meraki are used to monitor and configure thousands of switch over the web, right? So that means remotely you can view these switches as if they are in the same rack, so that means you can alleviate the IT staff at the location, right? So you can you maybe have one network engineer, right? The others are just normal IT staff, so they are not capable or not allowed to manage the switch itself. So you can do so remotely. You can access via cloud. Yeah. Okay. So quite advanced. Right, so Cisco Nexus promotes scalability. That means you can start off small, then you can start building up. Okay, you can see as the sizes increase, that means the capability increase. Right, so this is another Cisco offering. Okay, so if you're an ISP, so you're actually a service provider, you are looking at a larger set of number of users, right? And larger network access. So you start to have different needs, yeah. So this kind of switches basically have additional capability lah. So, for example, application intelligence, unified services, virtualization, integrated security, and simplified management, right? So we're going to look at some of this, for example, virtualization here later in the next chapter, right? And then here again, some virtualization. So we're going to talk about virtualization later. Virtualization basically simply provide an extra layer, right? An extra layer that that the client see, but it's just hosted, right? Hosted within your infrastructure. Okay, so that the client required platform can be supplied without you needing to physically install it as part of the platform for your devices, right? So again, we'll talk more about virtualization later on, but this basically switches are capable of providing that. Right, so form factors, basically the size and the configuration in physical form, yeah, of your switch, right? So there are many different types of switch that Cisco provides. You have fixed configuration, modular configuration. Fixed configuration means you cannot upgrade lah, right? For modular configuration means you can. It has a backplate that you can swap out, you can swap in, right? You can stack them, right? Some switches are stackable, some are non-stackable, right? So stackable usually and modular configuration and stackable usually, if your intention is that you're going to scale up your network in the near future. So you want your initial investment, uh, to be able to upgrade, yeah, upgrade. Okay. For fixed configuration, there's no possibility for that. Okay. Now, why would you want fixed configurations? Usually they are cheaper, right? Cheaper. And if you know that there is in the future, okay, that you're not going to scale up that quickly, right? That means uh, increase the number of devices or hosts connected to your switch, then you might balance between affordability and the scalability lah, right? So perhaps you, because of budget, you chose fixed configuration switches, and coupled with the fact that in the near future you're not going to, for the duration of the lifespan of that particular switch, you're not going to be able to need. That means there's no scalability in your network. You're not going to be needing to increase the size of your network, increase the number of hosts. Okay, so your company that you're managing the network for is going to stay mid-range, not going to suddenly explode and become a large enterprise needing, uh, suddenly a large network. Okay, right. So modular switches means fill replaceable line cards. It means you can open the black back plate and there's a place for you to insert depending on what module you purchase. So you can see this, you can play around with this in the Pocket Tracer. Some of the switch is modular. You can basically include what type of modules compatible with that particular switch. You can then provide extra functionality. Okay. Right. So if you purchase the stackable switches, right, you probably will be able to um, utilize special cables, right, that you can use to connect those switches so that the switch become as if it is one large switch. So this is not the normal way you connect one switch to another switch, right? Some stackable switch, they have a special port just for connecting the stackable switches together, right? Once you do that, one switch operate as if it's a single large switch, right? So another form factor you have to be aware so that you can buy the correct rack, right? And then also you can be able to judge how many switches can fit onto a rack that you're going to purchase. Yeah, usually we don't just place this on a table, we normally purchase a rack. Yeah, and then we actually fix it onto the rack, right? And this rack will be kept inside a lock room usually, right? So you need to be aware of the thickness of the switch, right? That means the height. Height. Normally the size, the length, okay, from side to side of the switch is industry standard fixed, right? So that you can, it's open. That means you can purchase any kind of rack, but how many switches you can fit onto the rack in terms of when you stack them up together, right? It depends on the thickness of the switch. Okay, and most of the time is fixed, and also based on standard, right? Okay, so port density talks about how many ports available for that particular switch, right? So you have, depending on the model and the price, yeah, more ports means That means everything else needs to scale up in terms of performance. Processor, RAM, because to deal with extra ports means extra hosts connected to that switch. So that means your RAM, your CAN table will be increased. Your RAM therefore needs to be bigger. The CPU to process those forwarding decision have to be also more powerful, and so on and so on. Right? Everything scale up in terms of price when you scale up in terms of port density. Capability of the switch also increase lah, right? So you will see that the price difference will increase depending on number of ports. So there are different configurations. So again, this is your based on your decision. Okay, you want to buy with a few extra ports. Normally, you don't buy ngam, right? Just in case you need you need to add another host. So you usually you basically plan to buy the switch. You have to leave some ports free for near future scaling up of your network. So normally it comes with 12, 24, and 48 ports configuration, right? Right. So but it's fixed, yeah. So once you buy 12, then it's fixed at 12. That means there's no way for you to upgrade unless this is a stackable fixed configuration, then you can stack, right? But another type is the model switch, right? Because you can you can add additional switch port by adding line cards, right? So the Catalyst 9400 switch supports up to 384 switch port interfaces, right? So you can see that perhaps they are empty at first. Then you purchase a line card and you place in, right? And you increase and you purchase more and more to increase to cater for your growth, network growth. Okay, so another things that you need to consider when you purchase a switch is forwarding rates. Forwarding rates basically is the speed in terms of per interval of time, right? So normally the interval of time is measured by seconds. So how much data can you forward within a second? So this is basically based on the capability of the switch CPU, right? Because the faster you go through perform all the switch features, yeah, like updating CAN table, locating the the port based on the destination address. So that means you want to index into your CAN table, right? All this and actually forwarding doing the switching and then forwarding it to the ports, destination port. These are how fast you can do that. That is the processing capabilities. So how fast the switch do this is actually will affect the again the which model, again how much is the price, yeah. Okay, so that means cheaper switches, entry level usually is cheaper. Performance wise, it will have lower forwarding rates compared to the more expensive switches, right? So if switch forwarding rate is too low, it cannot accommodate full wire speed communication across all of its switch ports. Means to say full wire speed is the maximum port rated speed. So 100 megabits per second maybe is the port. But if your switch forwarding rate is too low, we may not able to reach that kind of come close to that kind of theoretical speed, right? So if you want close to that speed, that means your forwarding rate must be fast, right? Just like this one forwarding rate is latency within that device. So if it's too low means latency is high. It actually add latency into your communication, right? Okay, yeah. So forwarding rates is important, basically, at the end of the day. It helps lower down intermediate device latency. Another thing that you might consider is power over Ethernet, right? Some of the switch may be placed in a place where there is there's no power supply, right? So without power supply means you cannot put a switch there. But if you still need to, instead of pulling that means rewiring your power, electrical power cabling, yeah, you can purchase switch that get its power over the Ethernet. That means the same wire, the same cable that brings in the data, right, can also bring in the power to power the switch. So this is what is called power over Ethernet, right? Most of the time we think about power over Ethernet is to power, sometimes power the access point, but a switch also, by using PoE or power over Ethernet, is able to operate without being attached to a power outlet, right? So, but it is expensive, right? So you have to make sure that you actually need the PoE capability, right? Multi-layer switching, we already investigated about multi-layer switching. It's called multi-layer because apart from layer 2, this kind of switch allowed to operate on the layer 3, which is to do routing functionality, right? So instead of using a router to provide connectivity between LANs or VLANs, you use a multi-layer switch, right? So again, you must know if you want to really embrace the Cisco distribution layer, core layer, so this kind of hierarchical networks, right? So at that second layer, you might want to, or distribution layer, you might want to have multi-layer switching routers only at the top layer, right? To to provide connectivity to outside networks. Okay, so in between the routers and the access layer, then you might want to have multi-layer switching, just to allow. This is for large networks, right? To allow the different networks LANs inside your organization to be able to talk to each other. That includes VLANs, yeah. Right. So if you want to purchase a switch, these are the business consideration lah. Normally the topmost is the cost, right? So the cost of the switch, you have to understand the more features you want for the switch, the costlier it will be. So it depends on the number and speed of interface. Number means how many ports, how many port interface, switch ports available. 12, 20, 12, 24, or 48, right? Okay, so always doubling, yeah, number of ports. And also, what the speed of the interface? Usually we have fast Ethernet, 100 megabits per second. Gigabit speed is only provided for intermediate device to intermediate device, switch to switch or switch to router. Usually, so that you have less number of gigabits port, but you have traditionally you have a speed 100 megabits per second is for normal access ports, right? So what other supported features are available, and whether it's fixed or modular. So it means it has expansion capability. So if you have expansion capability, means you're future proofing for yourself. So maybe the cost of that particular model will be more expensive, right? Port density, you have to consider how. It means you're planning your network. You need to know in your plan how many hosts there's going to be, right? So then you choose the right number of ports, the switch with the right number of ports. And also sometimes you want to give yourself a little bit of flexibility. That means if you think about it, maybe 70% of the ports are used, then you still have 30% number of ports you know empty for future use. All right, maybe that will be the best case scenario lah. If because you don't buy pots, ngam pots, because just in case you might need very quickly, you might need one or two pots extra, then there's no more. All right, so it depends on you lah, how much free pots you want to have. Okay, so just as a flexibility. Power, whether you want to provide no PoE or with PoE, right? Then reliability. So means sometimes we look at reliability as based on the branding, right? So we might have two switches, okay, similar functionality, but one comes from a very trusted brand, another one which is much more cheaper comes from possibly unknown manufacturers, new manufacturers. So it's cheap, but maybe not too reliable.
Dad, can I do you like? I need you to look my head.
Right, and then we have consider port speed, right? So this port speed, right, is of interest to the end users because, but again, it depends on because the host, what is the NIC port speed of the host, right? So there's no point to provide the high speed port speed on your switch if you already know the host PC speed is not going to achieve that. So you're talking about if you have legacy host with 10 megabits per second against the switch port speed of 100 megabits per second, for example, right? But if you know that the end users have got a 1 gigabits per second port, okay, and these end users actually work on um, graphic transfer or maybe work on multimedia, so they need to transfer huge number of files frequently, then 1 gigabit per second transfer on the host computer will be brought down by the port speed of 100 megabits per second at the switch. So you need to then consider, right? Maybe for this high-speed network, not all networks maybe need that. So maybe for that particular network where they need higher speed because of big data transfer requirement, then maybe you need to buy a switch with higher port speed lah. Frame buffers where the switch is going to store incoming frame. So there are many different types of forwarding, right? We can have a cut through, or whether you buffer first, you check for FCS, or you straight away forward, right? So the frame buffers affect that possibility. If you are using very high quality network cable with maybe even STP, a shielded twisted pair. So you're concerned about um, you know uh, corruption in the frames less. There's very few possibility that's going to happen. So you might want to consider switch which is not really need to have a lot of frame buffers because you're going to forward as soon as you get the frame, right? So scalability, you think whether you want to get the fixed configuration or the modular configuration, stackable or not stackable switch, because you're thinking about the growth in your network user. Okay, so that means you add line card, or you add stack another switch because you want to increase number of ports because the number of users, number of hosts increase, right? So you have to think about scalability also. So all this actually a business decision. You have to basically, if you're a network engineer, you have to talk with your IT engine, IT or your CTO, Chief Technology Officer, or your CEO to know their future plan, what's their vision for the company. Because, right, you need to provide the ability to scale up. But all the others also depending on their plans, what their business requirements are. Okay, and again, you balance that against the budget that they are willing to provide. Okay, it's a give and take lah. Okay, all right. So that's about switch. Okay, switch we are concerned with the number of host devices because switch connect them together to form networks, right? So when we look at router, yeah, we're thinking about the core, right? Core of your network. So this is a slightly different consideration. Router is never going to have a lot of ports because routers basically connects to other routers and or connects to switches. Never connect to a host except like in very specific situation. Maybe you connect to a server, right? Right. So router, we know the router requirements because we know their features, right? So they work as a gateway. They work as a way to um, transfer traffic from one LAN to another LAN, right? So one thing you need to know is that the interface or the interface on the router has to be very high speed because all the traffic will congregate on this router, right? So they need to have higher speed interface in the gigabit and above, right? To to be able to cater for the number of users traffic. Okay, because all the users connect to a switch, and the switch connect to the router. That means the router needs to handle a lot of traffic. Okay, all right. So other things that routers are used for is to limit broadcast domain, right? We know this one. Okay, they allow us to they act as a gateway. It means they allow us to connect remotely. Yeah, geographically separate location is remote, so we can connect to LANs remotely, right? They can also separate the LAN based on application or department, so logical separation of network, right? They also filter because we can do SCL, right? We can filter unwanted traffic. Okay, so they provide security in terms of that. So these are other features apart from forwarding decision, yeah, right? These are other features that is available on the router. Okay, so here we are shown Cisco Integrated Service Router 400 series router, usually for branch router. If you think about branch routers, then you'll consider this. Network edge router, again, at the boundary between your network, your large network, against the ISP or another different organization network. These are called edge routers, right? So it has to be highly secure to protect your internal networks. It has to be reliable, right? It has to be very high performance due to the fact that it is actually the single point where all traffic congregate, whether from your network going outside or from outside going inside your network, right? So under this, we have this model Cisco Aggregation Service Routers, ASR 9000 series routers. Okay. Service provider routers or even more capable, right? You can see because there are a lot of subscriber to to your ISP service provider, right? So the solution provided by these routers needs to be catered to the subscriber and the service provider needs, right? So here we have from Cisco. The offering is called Cisco Network Convergence System, NCS 6000 series routers. Very expensive, these routers, but very capable, right? So you can see example of this. Right, so industrial routers are designed to operate in extremely harsh environment. Okay, very rugged, right? So in factories, for example. So because your factories still need to be connected, especially now that we are entering IoT, Industrial Revolution version 4, Industry 4.0, right? We want to network all our basically machinery, okay, mechanical machinery inside our factory, onto the network. And the thing is, usually factories are very harsh environment, a lot of things going on, a lot of hazardous material. So any equipment we want to place there needs to be able to endure those harsh environment. So we are shown here the offering from Cisco that is meant to operate in such kind of factory or industrial environment, very harsh. So we have Cisco 11,000 series industrial integrated services routers. Okay, so these are offerings, so different. So from branch level to data center level to service provider level and even industrial routers, Cisco have offerings of routers. So capability wise, still the same. You still have iOS inside, but it's packaged under a protective shell. You can see here. Right. Form factors. Form factors are the size of the routers depending on its usage. So if you have a small branch, usually you get a small form factor router is enough, right? So if you ever come and visit our Cisco lab, okay, you can see that very similar to this, our router, okay, our hardware router, quite small size, right? It's small size because there is no need to connect host to the router. So it connects to another router and it connects to a switch. So therefore, it does not need too many ports. Okay. Right, so this one provide density and resiliency with programmability for scalable network edge. So this one is at the edge of our router, so they have to be high performance, right? So they do need to link up with many switches, right? And also maybe if you allow multi-layer switches, then it connects to multi-layer switches. And then if you're a large network, you have many multi-layer switches to connect to it. So yeah, you need to have many ports for those multi-layer switches, right? So it's scalable at network edge. This one is at the boundary. So this one separate your network with outside network, right? All right. So here we have an example where it's a system, Cisco Network Convergence System 55,000 series routers. This can scale up. You can stack them up. So this is for large data centers and large enterprise networks, web and service provider, wide area network, and aggregation networks. Aggregation networks mean a lot of networks congregate here or is aggregated and reach this routers. So these routers therefore looks like a switch, with a lot of ports. Okay, but these ports are not for hosts. These ports are for other routers and other multi-layers, switches, or even switches, right? So therefore, these have to be very high performance. This one is an example. You can see the ruggedness of the design. Okay, so it's meant to be able to withstand harsh environment, right? So you can see in terms of functionality, it's the same, but in terms of the design, it's more hardened, okay, more rugged. Okay, so right, so that's the end of this section. So what we'll be looking at is the two main offering from Cisco, okay, for switches and routers. And you can see that there are different models, okay, catering for different features and functionalities, okay, from the small branches, home office, okay, sorry, not home office. Of home office use no, not only use Cisco because it's too expensive. Small office lah, small office, small enterprise, maybe branch campus, something like that, until the large enterprises, okay, where you have catered for hundreds of users, to service providers where they cater for thousands of users, right? So that includes switches and hardware. So again, I will bring you back to the early here, okay? Or maybe this one, okay? The hierarchy, right? So you can see what kind of switches you purchase at the access layer, what kind of switches you buy at distribution and core layer, and then routers, okay? Right, 3-tier is for slightly larger networks compared to 2-tier. 2-tier, 2-tier, you don't have separate core and distribution. That means you combine them together. All right. So this is how Cisco see how you can provide um, the different network devices for different layer and how they function. Okay. So again, that's why we have a look at here. We end up with the choice of different types of switches and different types of routers. And what to look out for, yeah? What to look out for when you choose. All right, so we finished that part. I'm going to stop recording so that we can see the separation of the concern, right? And I'm going to go to the next part, chapter 11, part 2, which is network troubleshooting, right? So here, network troubleshooting, we're going to talk about this, what is needed, how to approach when you a systematic way to do network troubleshooting. All right. So I'm gonna start recording this. Okay, so let's start. Network troubleshooting. So so far, you guys have been doing troubleshooting, right? When you're doing the learning the configure, because you're not used yet to the configuration, the commands and all these things, right? So that's why sometimes you got errors. So every practical exercises, you are asked to verify and then do troubleshooting if there are some problems, right? That gives you a good foundation, an idea, right? How to locate some of the errors. So here we're going to present you a more systematic way of dealing with network problems, right? Okay, so the first topic is about documentation, right? So small network, therefore maybe you can ignore documentation. I suggest that even for small network, you still do documentation, but if you don't do documentation, it's not as difficult as if you have a large network or a very large network where you don't have documentation. It's going to be very painful to do so any sort of troubleshooting or monitoring, right? Right. So here this topic will look at network documentation. You need to document your network, right? Then we talk about one of the way to do troubleshooting. So we look at the troubleshooting process itself. Okay, how do we do troubleshooting in a more systematic way? Systematic way means you just follow the, the steps, right? So that you cover everything, right? So that you don't miss out something, right? So if you finish one step, you know, okay, you covered that step. The next, go to the next step, right? Along the way, you might find out what is the problem, all right? Then what are the tools that you can use to do the troubleshooting? Okay, these tools are networking tools, right? And then we look at some possible symptoms, that generic symptoms that is encountered by network administrator. Okay, typical ones lah, typical symptoms. And usually, what are the causes of the network problems? But we codify the knowledge lah here. Okay, and then finally, we look at how to troubleshoot IP connectivity. IP connectivity means host-to-host connectivity is faulty. That means you can't have that host-to-host. So how do we troubleshoot that, right? And here we use the layered model, okay, to troubleshoot that. That means since we know the implemented TCP/IP layer model, right? So we can approach troubleshooting layer by layer. So again, it's a systematic way. Okay, so let's first look at network documentation, right? So, okay, we have to say that every practical that we've done so far, we always help by the first table. Every packet tracer activity, you have at the very basic a table there indicating what are all the you know, the IP address and all the whatever name of VLANs and whatever. Okay, so for your own network, you should have this table. Not only that, you should have a topology diagram. The first thing you should always do when you are looking at the network is to understand it, is to look at the logical and physical topology diagram. Physical, yes, you can place where everything is physically and how, what kind of wiring connect them all. But more importantly, the logical topology diagram shows you the logical areas of your network, the IP addressing, the VLAN name, and so on, right? Okay, so if you are troubleshooting just now by layer model, if you start with physical layer, you will look at the physical topology. If you start from the logical layer, then you will look at logical network topology diagrams. All network documentation should have this topology diagram, right? And then you must have device documentation. So for each device, you have that information. So host, basically, you don't have to have information for each host, but at least you need to know the addressing. Okay, the addressing. So perhaps if you have hundreds of devices, addressing one by one in the documentation, perhaps it's going to provide very tedious lah. But at least range of addressing you should at least have lah, right? So network performance baseline documentation. So this again, I think this first time you hear this. Baseline is normal daily usage performance. Okay, that's your baseline. So if your network is underperforming, means it can't achieve the baseline, something's wrong. If the network performance go beyond the baseline, then you have to consider upgrading already. Upgrading by finding which area exceeds your baseline. That means you're thinking ahead, right? Before the network performance reach a saturation level whereby everything, all the traffic becomes congested lah. Performance becomes bad compared to baseline. So you need to do something really in terms of upgrading. Okay. Right, so the documentation should be kept in a single location, and you should have a backup documents just in case that single location is compromised. It can be anything. It could be burned down, it could be flooded, it could be stolen, it could be whatever, right? And then you lost that single documentation. That's bad. So you need to have a backup documentation, perhaps as a digital format, or usually we have digital format. We don't normally print it out, but if you do as a policy print it out, hard copy, then you should have a digital format stored in a different storage, maybe in the cloud rather than your own computer, right? Right, so there are two types of topology diagram. Just now I talk about physical topology indicates the exact location based on the map of your site, yeah? Exact location of any of the devices, whether it's server, router, switch, or your host. And in fact, even the wiring may be shown, right? It may be shown. Maybe it's not as like this. Maybe I've seen drawing a physical topology where the wiring is placed along the walls or whatever, underneath the whatever, or on top of the ceiling. That it should basically show the exact physical location of everything, including the media, okay, including the cables, right? And usually, sometimes they also provide the power cabling and socket, right? So that you can plan, okay? If you're planning, to provide the networks, you need to plan where the plug from the switch goes to, right? Where you place the rack, and you can lock that rack even within the wiring, and then where the cable runs through, right? And where it ends up in maybe a socket on the wall, because nowadays we can have a plug, Ethernet port plug on the wall, and simply user can just simply connect to that wired, connect to that port, right? So all this can be inside physical topology. All right, we're not concerned about the logical part. We know we need all the port number because we need to know how to plug in the cables, right? But the addressing, all this, we're not concerned about here. It's the physical infrastructure here. All those other things, like IP addressing or MAC address, or all those VLANs, whatever name of the LAN, VLAN name, or all this should be under logical topology and should be documented at the logical topology diagram. Right? Right. So if you have devices, router, switch, and servers, maybe PCs as well, right? If you keeping track of PCs, because a lot of times management require reports. Oh, how many hosts do we have, right? So at least you know how many hosts and what you have. If you have put manual IP address, then you need to know. If you put DHCP, then just put DHCP for the particular host, right? So this is an example, and this must be done up to you. Updated when there is a change in the topology. It is an addition of new device, addition of host. Then you keep your record up to date. So you can see some examples here. Router device documentation. You can see the header, the name of the device. Sorry, the device, the interface, the model of the device, the description, location, iOS version, and the license for that iOS, and then the interface on that device, and the description, the IP version 4 address, IP version 6 address, its MAC address, and what routing you use. And similar with the switch, right? Switch configuration and end system or the host documentation. Like for example, server here, what OS is running, services are available on that particular server. What is the MAC address for the NIC? What is the address for IP version 4 and version 6? What's the default gateway for that particular host, and DNS server for that host, right? So all this, why we need this? Because if we need to configure, let's say for this end device here, server 1, right? PC 1, maybe there's a corruption. Okay, hopefully for servers you have backup, so basically just restore and everything's there. But PC maybe it's not backup. Corruption. Now you have to redo the configuration. So at least when you have look back through your documentation. Oh, for this PC1, actually the IP address is this, and it's easy, right? Easy for you, easy for your staff, okay, for your IT staff, right? So you need to keep network device documentation, and then establishing network baseline. So you need to know, based on day-to-day operation, what is the average performance of your network. So this becomes your network baseline, right? So you need to collect data, right? And um, when you're doing this, sometimes you can notice where if there's any congestion, or where there is part of the service, network service, that's underutilized. Underutilized means below the the baseline. Congestion means above baseline, and or congestion is part of your baseline. So if congestion is part of your baseline, as usual, you don't want congestion. So when you're during your creation of your baseline, you notice congestion, then you need to do something about that congestion. Okay, and once you deal with the congestion, maybe upgrading or doing some setting configuration, then you need to update your baseline to the new baseline, right? So how do you do that? How do you do a network baseline? So step one is to determine what are the types of data you can collect, because you need this data to establish the baseline. If you collect too many data points, it's very difficult for you to analyze and determine, right? Determine what to make of the data, right? So start small, can fine tune as you go along. Maybe you say, oh, I need this, then you decide to collect that. So some starting point, maybe interface utilization. Okay, that means you see what is the average, or the max, minimum, and average bandwidth data data traffic coming from this particular interface. Okay, maybe you don't start with the access port. Maybe you start with the switch port to router interface, switch interface, switch to switch interface, because these are the part where if there is congestion, then right? And this is the important part lah, right? Maybe you collect data there, right? CPU utilization, maybe for servers. Okay, you want to know CPU utilization. Maybe your server is handling DHCP or DNS or whatever. So you need to know is whether the server is still capable to cover, right, normal everyday usage. So you look at CPU utilization. High CPU utilization all the time means it's time to upgrade. Identify devices and ports of interest. Just now I talked about, so you can see the ports that leads to somewhere some other device are your device or ports of interest. Okay, highlighted here. Okay, maybe you want to collect data there, and it will tell you something, right? And then how long are you going to collect the data to determine your baseline? Okay, at a minimum, a long work week, or a long 7 days, the whole week's days operation. No matter whether Saturday and Sunday, less people, but then it will be your baseline for weekends. And what is your baseline for weekdays? And you can then see from there, when you analyze which day is a peak day, right? And sometimes it's not because of your own employees. Sometimes because of which day of the week you have so many customers, and the response is that they are your customers maybe generate transaction at the point of sales, and point of sale is your host, and then the transaction travels through your network, right? Switches. So that means you can see You can see this. And then should be no more than 6 weeks unless you are targeting to check long-term trends. So in general, 2 to 4 weeks baseline is adequate. This is about half a month or up to 1 month, right? 7 days is the minimum, right? And then you need to periodically do this. Okay, check your baseline and update it, because this will tell you whether the requirements of your network is satisfied. And then due to, sometimes your business react, right? More and more people start to come to your business to purchase your product or service. Means more and more transaction, more and more stress put on your network. So maybe when you check again your baseline, it changes. It becomes now a baseline as increase. Okay, so that means you have to decide, okay, whether an upgrade of certain devices. You have to check, right, which interface, which where is this increased network traffic, and maybe upgrade there. Okay. So data measurement. So these are all the summarize here, all the commands that you can do. Okay, and from here you can actually collect your data measurement, right? Okay, so we move to the troubleshooting process. Okay, troubleshooting procedures. This is a simple flow chart. Okay, this is the basic troubleshooting flow chart. So basically, stage 1, you gather symptoms. What are the symptoms of a problem? From there, you can try to isolate the problem. And then after that, after isolating the problem, you basically have an idea about the problem. Then you start to think about what is the corrective action. Then you implement it. Then you decide, is the problem fixed? Then either no or yes, right? If yes, document your solution and save the changes. And then then no more problems. If not fixed, no, then you have to redo your steps. Okay, you think about what other corrective action you can do. Or if it's solved, but then it creates another problem, then you still have to redo everything from stage 1 for that new problem. Okay, so sometimes your fix may introduce a different types of problem, so you have to redo this stage, right, to solve this stages 1 to 3. Okay, and only stop when you got yes here, and then you document and save your changes. Right. So here is more detailed steps. Okay, and the flow chart is shown here up here. Right. So define your problem, gather information, then you analyze your information, then you start to eliminate possible cause. Okay, you can say, oh, maybe this, maybe 1, maybe 2, maybe 3, maybe 4, maybe 5. These are 5 causes. Then one by one you eliminate, okay, until you left with 1, and you think that is the cause of the problem, right? And then you propose, once you understand the problem, then you can propose what is the solution, right? And then you try to implement that solution, which is testing your hypothesis, right? If your solution is correct, then you have solved the problem. And then you can have to document it. Document both the cause and your solution. So this actually should be put into some form of knowledge base. So if you yourself maybe forgot already about it, okay, then you can confer back into the knowledge base. Okay, if it's similar problem, then you can try the solution. Or other people, right? Maybe you go on holiday and other people is drafted into to be in charge. So you're on vacation, you don't want to be contacted. So maybe because they have that knowledge base, that way you document all your cost and solution, they can solve it without you, right? Right. So what about if you're troubleshooting and you need some information from the users? So these are the type of question that you can ask the end users. Okay. Ask pertinent questions simply means ask the correct questions. Okay. So things that you can ask is ask them specifically what is not working, or ask them what is the problem. Sometimes they give you a problem and the problem is indirect, right? So it's your skill to ask the correct question so that the indirect reply become a direct reply. Because sometimes they talk about the network problem, but they say my browser is not working, right? Because they do not know enough technical details. So to them, their browser not working. Okay, so it could be application level. Okay, application layer problem. There is something wrong with your browser, because browser HTTP is application level, but it could be the network cable, the whatever lah, at the lower level, but they simply cannot describe to you. So they say my browser doesn't work. So you know you have to then say, oh, when you say browser doesn't work, then you start to maybe it's an error, corrupted browser. The app itself is corrupted. The app itself is not up to date, right? But it could be. So you ask, okay, so when you say doesn't work, does it doesn't work on every page? That means if you try to connect Google, you try to connect something else, or then you start to, if it's not the browser, sometimes say, oh, if I open Facebook can, but Google cannot, then why? Maybe then it leads to other things. So you have to ask the question, correct question, like being a detective, right? Determine the scope of the problem. So scope is this is this only the user affected, or is or every user in the same LAN affected, or just one LAN affected, or other LANs also affected with the same problem? Okay, which device it's have problems on? Okay, determine when the problem occurred and occurs. Means, okay, is it happen on a specific time, specific date, right? Could be there was it happens when there's a network usage spike, right? Is it happening at a constant time, or as constant reason, or is it unknown? It's intermittent. Can happen sometime, not at the same time. Not it's not a everyday occurrence. It's only happen sometimes or regularly. Okay, find out if there was any change. Maybe there was a Windows update, or there was you know uh, maybe you make changes in one of the switch. You make changes in something in the ACL or something. So it may be related. Okay, is there anything that changed since the last time when it's still working? Right. So you have to become like a detective to use your questioning to eliminate or discover what is actually the problem. What works, what does not work. Right. So this takes skills and knowledge, right, to do this effectively, knowing what question to ask. Okay. Right, and then you can also do some of your sleuthing by getting the information yourself. So you get the information. So you need to know all the troubleshooting commands, right? For like ping, traceroute, telnet, SSH, show IP, whatever info within switches or routers. This to collect information and also to conduct your investigation. Can I ping or not? When I ping, which host can I ping? Which host I cannot ping? Can I ping beyond my router? Something like that. Okay. Okay. Troubleshooting with layered models means you understood what is the OSI layer and you understood what is the TCP/IP layer, right? So when you troubleshooting with layered models means you go by layer, whether you start at the top or you start at the bottom, or start from middle and go up or down, right? So this is systematic. if you say you start with application layer, then you just check the application itself. My browser doesn't work, so you check, is the browser the correct browser? Maybe the user suddenly installed some other browser, or browser is outdated and not updated to support a certain website, things like that. So you focus on the application layer, right? If you say physical, then you have to look at the physical topology diagram, and you have to look at the cabling, whether it's disconnected, whether there's interference on the network, all physical layer kind of thing. Sometimes incorrectly terminated cable, that means RG45 there, is loose, right? Someone accidentally kicked the cable or something like that, right? And then it become loose. So that's physical problem, right? So different layer needs different way to investigate and different solution, right? So you can do this, whether bottom up, from bottom you go up. Okay, good approach if you suspect it's a physical problem. That's why you start with physical layer. Top down is if you think it's software, because application layer is software. So if you think it's software based, then you start from the application layer going down, right? Divide and conquer means you don't know physical or software, so you start in the middle, maybe layer 3, and then you go up or down depending. If you start to investigate up, and then you start to think, hey, yo, so you go up, right? Or you think, oh, when you're testing here, then you think it's going down, going physical, so you go down. Or you test both up and down, right? Follow the path, you follow the traffic from source to destination, right? Follow the traffic means you try to, let's say, you follow the traffic is IP. So you use ping. You ping the nearest gateway, right? If you think it's layer 2 frame, then you start to check whether you can go into the, let's say you're using Cisco switch. See whether you can go into the Cisco switch, right? You can ping the Cisco switch. You can then from there you go to the Cisco switch, and you do show information and check against your documentation, see any changes. Follow the path means from the source to destination, you follow until you find a block, a place where the traffic is stopped. Okay. Substitution, you physically, okay, you say, oh, I know I have a secondary copy, and I restore the configuration into this secondary copy. I simply substitute the problem device with the new one. Okay. Then if it works, that means something there is a damage. That you can allow the system to network to recover while you check the faulty device. All right. So this is another way, substitution. Or you compare the current device with a device that you know is working well. Okay. So you check the information. You get information from this device. You check this device. You compare, right? Educated guess here, you have to be very experienced. It's very difficult to do educated guess if you don't know what you want to guess in the first place, right? So this one is actually good for experienced network engineer or network administrator. Okay, right. So which one you choose? Okay, so you what lah? Depending lah, right? Depending on situation. Again, this figure, you follow this type of troubleshooting if you discover what type of problem it is. So let's say you analyze the symptoms. Okay, you determine the type of problems, whether it's software or hardware. Hardware, use bottom up. Software, top down. Analyze the symptoms. Then you want to apply previous experience because you experienced it before. If not, then it's new problem, so bottom up. If it's you experienced before, divide and conquer method. Okay, if you're experienced, right? All right. So actually, this one is not troubleshooting process. It's troubleshooting tools. All right. So we're going to look at what tools you can use. We have network management system tools, and then we have knowledge bases. This is knowledge bases that I was talking about. If you found a problem, you managed to solve it, you need to document that and put it as part of your knowledge base. Even you yourself, after a while, will forget. So this may be useful to you as well. And this will be highly useful to your colleagues or to other people, right? And then because we need to create a baseline, right? So any changes from the baseline means there's something that you need to do, right? So you need baselining tools. Okay, so this help you to find out what is the baseline. So this may be a network diagram, network software, hardware, cost-effective baseline network bandwidth use, right? So maybe software, maybe hardware, something that can help you to determine what is your baseline, right? So protocol analyzers is one of the software that you can use. This one is Wireshark, right? A Wireshark can capture frames and all the PDUs, like all the layer PDUs, from frame all the way to network layer, the packet, all the way to application layer data, right? So you can see it's capturing everything. So it's basically, even though the frame is not meant for you, you can still capture. That's why Wireshark is actually such a helpful tool. It's like simulation mode in packet tracer, right? So what about hardware? Hardware, you have digital multimeter. This basically checks for voltage, current, and resistance. All right. So in fact, if there's any part of your cable, because maybe it's disconnected inside, right? Inside, not, and also maybe the wires runs through cabling that you cannot see because it's embedded, right? And then somehow the rats get into it, or somehow it's get, what's happened. So you want to see whether the current, there's any changes, there's even current there or whatever. What is the voltage? What is the resistance? You need multimeter. Okay. Cable testers are basically, last time we do have cable testers when we're doing FCN and ask students to create the straight through and crossover cables, and to make sure that they actually uh, connect the correct cable colors to the correct pins position on the RJ45 connectors. We actually use cable testers, right? They can immediately show you if there is disconnectivity between one pin to another pin at the end of the cable to another end of the cable. All right. So this is one example, very good. But of course, you have many cables. Those are for copper wire cables. Cable tester can also work on fiber optic cables. Yeah. So different cable tester for fiber optic. Right. All right. So again, here, cable analyzers. This one is a higher level compared to testers. This one actually to see whether the cables and for whether copper and fiber is up to operational use. Okay, you can see, test, and certify, right? Certify. So usually we want to see, let's say, those installers, they install, let's say, Unify. Okay, they want to check. They do have this, the tools, right? They want to check out. They connect the fiber cable to their tools. They can see, the connectivity, yeah, okay, and what in terms of data transfer speed and all these things, you can see there, right, up to what it's supposed to be, right? And then we have portable network analyzer. This one special device to troubleshoot and switch networks and VLAN. So this, so you don't have to, carry around your laptop or whatever it is. So just portable device. You can just plug into any of the port or cable, then you can detect, right? Okay, so, and then we have Cisco Prime NAM or NAM. This is a browser-based interface that can display to you the device performance analysis, both for switch and routers. Okay. Right. So remember syslog. Syslog server is a place where you, for the AAA or for auditing, every error information or otherwise what you configure from any of the device like switch or router will send message to this syslog server. So syslog server will keep a record of everything that happened. Okay, so there are many different levels you can activate, right? So if you, depending on what you want to troubleshoot, you may want to filter the log by whether you want to see warnings or errors or critical or emergency or whatever level, right? So this become a very useful tool, okay, not only for auditing, but actually for troubleshooting, because you can see whatever kind of things. Let's say you say one user say, oh, I cannot connect to network. Then you check your syslog, you can see there's error enabled, so error disabled, sorry. And you check, because violation, security violation. Straight away you know, right? Because you see inside syslog server and you already ask syslog, the switch to, send any of these error disabled messages to the syslog server. So straight away you know why that user cannot connect anymore, because it's disabled due to security, problems, right? So you can use syslog server as a troubleshooting tool. Right. So next, we're going to look at the symptoms and causes of network problems. So these are basically just guideline. Okay. If you see kind of symptoms and then you can see what causes these problems. Right. So let's say you have established a baseline, and then when you test again, right, do the same data collection as when you perform for the baseline, you notice that it's now lower performance from your network. Okay, right? So then, of course, if you want to compare, you must have done your baseline first. Then this one is you do the second time after maybe some period of time, just to check. Then you still notice this difference, okay, between the new baseline and the old baseline, right? Okay, so maybe there's a growth in your network, right? The usage is more, your more transaction, because the more customers maybe visiting your physical store, your online store. It depends on what is your business transaction, right? So there is that means overloaded. Your server become overloaded, or is considered now underpowered, right? Due to the increase in number of transactions, perhaps, right? So maybe also the switch or router is overwhelmed already. There is now, due to increased traffic, there's traffic congestion. Okay, so the switch you purchase is now no longer able to sustain it. Okay, loss of connectivity, maybe it's a failed or disconnected cable. A lot of times it's physical. Someone kick and then disconnected, or the RJ45 connector is loose and somehow it's pulled, and then the pin doesn't connect to the wire anymore. Then you also will have loss of connectivity. Okay, you want to verify whether there is loss of connectivity, you can do a simple ping, right? So you can see if it starts to become loose, it's not directly loose anymore, but sometimes work, sometimes not. Means your connection there is loose, sometimes it's connected, then there is connection. Disconnected physically, then there's no connection, right? This can indicate intermittent connectivity loss, not regular. So kena goyang sikit the cable, then lost connection, right? This example. Right, so another symptom is network bottlenecks, or there's congestion, right? So because routers usually choose the main route as the best route as the main route. Okay, so if suddenly you got congestion and you check there's no more increased traffic, okay, because of transaction, okay, then you might think that, hey, hang on, maybe one of the main route from the router is down. Okay, so now the router is choosing the second route. Okay, but the second route is not as fast as the previous route. Okay, so that means it's suboptimal. Okay, so that's why there's congestion. Okay, so if that happened, then of course, I recall that last time, due to earthquake, the main underwater cable connecting us to the internet that goes via Taiwan was disconnected. So our internet suddenly becomes slow because now we are using a suboptimal route. Oh, now there's no load balancing. Now all traffic goes to our secondary route. So there's a network congestion there. That's another example in terms of wide area network, right? High CPU utilization indicate that the hardware cannot cope already, right? Cannot cope with the application. So it could be that there's a new application installed, or the whatever it is that cause the processor cannot cope already. So you notice that high CPU utilization is happening at the server or at the host, right? The server is more critical. Okay. Console error messages can happen. That means could be a physical layer problem, disconnection, right? Or security problem, like we talked about earlier on. And usually this kind of messages, console messages, is sent to the syslog server. So you can go to the syslog server to check out the logs, right? Okay, so this table shows what can happen at the physical layer. So power related, can tell you all the problems lately we're having in Penampang about the power cut, right? Has caused for electronic. If you have electronic, sometimes even with power surge protected socket, can still cause problem, right? I have one of my power adapter. I think it's damaged already. Okay, after several times the power cut. So you can resolve that by having a PSU, a power supply, uninterruptible, UPS, sorry, uninterruptible power supply, so that it it doesn't suddenly cause your machine to shut down, right? So you can do a proper shutdown if there's no power, right? So physical wise, there's always a reason why overheating or just because of failure of a certain part of the hardware, right? So these are because of the power surge, or whatever reason lah. So that's why you always protect your using a surge protected socket lah, right? Power related. Hardware faults, faulty or corrupt NIC driver files, bad cabling, grounding problems, okay, can cause network termination errors such as late collisions, short frame, and jabber. Okay, I am not sure how NIC driver files can get corrupted unless there's corruption that happens due to, you know, you switch off your your computer, without proper shutdown, then some files get corrupted, things like that. But cabling, we know lah. Okay, in the first place, maybe the cables are not done properly, right? We have this happened to us before, right? Cabling faults, damaged cables, improper cable, poorly crimped connectors. A lot of problems actually come here. If you do your own connectors, you cut your cables, you save money lah, right? But if you don't do it properly, poorly crimped connectors means the connector doesn't grip the jacket or the cable properly, it can get loose, and therefore the wires can get disconnected from the pin, right? Attenuation means you go beyond the limit of the cable length. Okay, if we said, okay, theoretical limit 100 meter or 10 meters or whatever, don't go ngam, leave a little bit. Okay, because usually in real world term, you can't really reach that length. Okay, so maybe if you say 10 meter, maybe you just reach 8 meter, something like that, right? Attenuation can cause loss of that means corrupted signal, corrupted data. When corrupted data in the network means it's retransmission for TCP, so it makes your network slow. Noise means interference. So if you're not using UTP unshielded twisted pair cables, then yeah, it could be affected. Okay, some I've noticed some technician, when they cable, they actually include the UTP cable with the power cable side by side inside the same conduit. I also don't know why. you know, and if it's STP, shielded, then that's okay, because electrical cable produce EMI, electromagnetic interference, and can actually interfere with the the encoded data signal inside the UTP cable. Interface configuration error simply means the clock rate for serial cable, right? Incorrect clock source, interface not being turned on, no shutdown is not being tagged, right? Then of course, then there is this is interface configuration errors. Exceeding the design limit, if you don't push it until the maximum capability of that particular component, right? So for example, I can think about my processor. My processor, yes, we know we can push it to 100 percentage of usage, but if you keep hitting 100 all the time and your processor is heating up, if you're just using a fan, right, and this affect the GPU, then you're gonna damage your processor or your CPU or GPU quickly. So if you want to reach that kind of processing, I think you start to think about upgrading your processor already, right? So meaning exceeding the design limits. Another thing is about temperature. Maybe you don't hit 100% CPU usage, but you're reaching 80 to 90% because you're pushing it, you're overclocking it, and you're reaching 80, 90%, 90 degrees Celsius, which is not good for your processor. It could shut it down because it's protecting itself, right? So you can see exceeding design limits, and when we talk about CPU overload, it's also there's a design limits to it, isn't it? So this CPU can be your host CPU, can be your GPU, can be your switch CPU, it can be your router CPU, any device CPU, right? All right. So next we look at the data link layer troubleshooting, right? So data link layer means just above physical layer, isn't it? It's where you have your MAC address. So no functionality or connectivity at the network layer or above. That means your layer 2 maybe got problem. Okay, so check it. Check your frame. Okay, exchange your frame. It means at layer 2, maybe your switch problems, right? Network is operating below baseline performance level. Remember remember that the STP also try to choose the best path and disable the secondary path. if the other path go down, it will start to choose the secondary path, which is not as fast as the initial path. Again, that could happen. Then your network is performing below your baseline performance, right? Okay, right. So, and if frames are being dropped, if it's a TCP, then you will start to notice that your network is becoming slower and slower. Frames are dropped because of corruptions. Okay, the FCS trader part of the frame is checked, and if the frame is damaged, frames are dropped. Okay, so if you use ping, your reply will be slow, right? Excessive broadcasts. Oh well, why so many broadcasts? I can think of the only reason why you have broadcast is because of the switch problem, security problem, remember? Or the ARP, there's a lot of ARP traffic, okay? But here it says application can cause it, or your layer 2 broadcast domain is too large, your network, the LAN is too big, okay? Simply there's so many ARP traffic flowing in there that excessive broadcasts, right? And then console messages. Router send message after you detect a problem with interpreting incoming frames, encapsulation of framing problem, or when keep alive are expected but do not arrive. So console message that indicates a data problem is line protocol down message. Okay. All right. So this the lettering layer, we continue with the few more, right? Encapsulation error. So encapsulation error simply means as a this network stack problem. You see the sender place some information in a field that is not what the receiver expect to see. So encapsulation error is there. Address mapping error. Layer 2 and layer addressing is not available. Framing errors. That means this one physical, right? So physical will cause framing errors. That means encapsulation for the frame error, right? STP failure or loops because no ports in the redundant are blocked. So the STP didn't work properly. Then you have loops, then you have broadcast storms, and then your network down, right? Okay, or the STP cannot converge somehow, right? So this one you have to check why STP cannot converge. If STP cannot converge means the topology keep changing, right? So could be error, okay? Could be error from the switch itself, or it could be an attack is happening. Right, so what about network layer problem? Network failure, if there's a network failure and you determine that it's a network layer problem, if you're checking network layer, right? This, if it happens, it will affect all users and all application because users and application, they work with IP address. So if layer 3 is having problems, IP address is affected, then application will not work, right? This one definitely will be noticed very quickly because simply no networking application or network capable application can work. Therefore, it will be noticed very quickly, right? Right, suboptimal performance. Suboptimal performance means your network is slow, laggy, it's not performing at the level that you expect, right? Now this one, suboptimal performance is usually harder to detect. It depends on what is application destination type of traffic. Okay, so I give you a reason. Suddenly it's very, very slow. And you think it's a network problem, right? but actually it's because someone is using BitTorrent and utilizing all the bandwidth to download a torrent, right? So no matter how you detect, right? You have to you cannot detect any error. There's no reason, but until you actually do packet level packet analyzer, and then you check what is the type of traffic, right? Then you check which interface is very high traffic, right? Bottleneck, so much traffic going on from this particular interface, and then you look into the PDU, and then you check, oh, what is the protocol? Then you say it's BitTorrent. Then you realize, oh, okay, so because this, right, could be caused like that. Okay, so not all suboptimal performance that due to that, but it's harder to detect because it could be something non-network related. Could be the user is using a lot of bandwidth, right? Okay, so general network issues often change in topology can have an effect on other areas of the network, right? So the way to detect this is to find out whether anything has changed in the network. If you document every change to your network, usually this one you can easily diagnose just by looking at your documentation, right? Okay, if you are in charge lah, right? So if you're not in charge, then you might ask the person in charge, network administrator, to say whether did he change anything or not, right? Did he add a new device, remove any device, or change the topology somehow? If it's connectivity issues, right, you need to check power, environmental problems, layer 1 problem. These are physical, cabling problem, bad ports. Maybe simply it's not your network. Maybe the ISP is down, connection at the ISP. Can also call them to see whether there's any problem at your particular port, right, at the ISP site. Right, so another cause is routing table. So for routing table, you just use the show info command to check the routing table. So see whether there are any missing routes or unexpected routes added to the routing table. Right, and then EIGRP or OSPF, they can form adjacencies with their other routers, right? See whether they suddenly cannot form adjacencies. That means they cannot form adjacencies, then they cannot share routing table info. So that's when the routing table has not enough information, then it cannot route. Then that's why there's connectivity problem, right? And this one also can cause it. Okay, so topology database, check the table for anything unexpected, any missing entries or unexpected entry in the topology database. See whether anybody unplug something, add something. This can change the topology. Any change in the topology can affect connectivity. Right? Then a transport layer, because ACL can be used to block ports, right? To block ports. Okay, you can block HTTP. So all these ports are at transport layer, right? So then you have to check ACL if you configure ACL, or maybe you have misconfigured your ACL, right? So you need to check whether if certain transport layer protocol cannot work. Okay, then the port, then you check your ACL whether it's been blocked. Okay, sometimes the order of how you place your N3, okay, can accidentally block, okay, a certain port. So your N3, when you're doing your ACL, should be start with a specific. That means if you want to block specific IP address, block specific port, and then you end up the next one be more general, then the next one more general. So from specific to general, this is the order of your ACL entries. Okay, you know there's an implicit deny any. Okay, sometimes we forget. There's a, at the end there, it's hidden, it's implicit, but we know there is a deny any at the end. That can cause problems as well. Okay. Then wildcards. If you make a wrong wildcard and you type wrong address, then wildcard is dependent on the subnet mask. If you accidentally calculate or provide the wrong subnet mask or the address, then so it cause error as well. Okay, or maybe you select the incorrect transport layer protocol. Okay, maybe instead of TCP, you put UDP, or UDP instead of TCP, then also a problem as well. Okay, so again, maybe mistake on the port number. Sometimes we type, okay, especially if we don't memorize the port number, that means we have to be very careful the port number, because you intend to block a certain port, suddenly it's a different port, actually. Okay, so you mistype or misunderstood which port. Okay, and then maybe you wrongly use established keyword. If you wrongly use established keyword, then an expected result. Yeah. Okay, misconfigured ACLs often cause for other protocols. Okay, uncommon protocols. Maybe it's not TCP or UDP, other types of protocols. Okay, but this one is quite rare. Usually we only use TCP and UDP most of the times, because proprietary protocols seldom used anymore. Okay, because here we talk about network address translation. Okay, remember to map the private addresses to a global IP address. Okay, so it's for IP version 4. Okay, so transport layer also include NAT lah, network address translation. Okay, so boot TP and DHCP. Boot TP basically to boot a workstation or host based on information provided via a server at the point of starting up the booting up, right? But this is legacy now. Most computer now use DHCP. Okay, right? So DHCP have trouble operating over a router which uses static or dynamic NAT. Okay, because the router, okay, the NAT is already at the router. The NAT actually map between private addresses and the global addresses. So you can imagine DHCP is tasked with providing an IP address that is from a pool of IP addresses. So these IP addresses could be private IP addresses, so for DHCP for within your LAN, or it could be a DHCP providing global IP address from your ISP to provide for your router. Okay, the one facing the internet. Okay, so can cause problem lah, because if you're trying to operate DHCP beyond a router, gets confused lah. That means private cannot be provided beyond router, right? Okay, and global is provided for the router interface, not for any for IP version 4, for not any of the addressing for the host inside your LAN, right? Okay, so next one will be example DNS. DNS server resolve IP address, but because NAT hides the content of your network, because NAT makes you map the private IP address with the global IP address. So DNS server does not really have any idea about the addresses inside, right? So you have to enable this IP version 4 helper feature. Okay, if you don't, then DNS probably cannot work if the DNS is outside your net router. And then we have SNMP. So an SNMP may not work over NAT router because of the translation of the addresses. And you need the IPv4 helper feature. Similar problem with DNS. Okay. Tunneling and encryption protocol require that the traffic must come from a specific UDP or TCP port or use a protocol at the transport layer, and this cannot be processed by NAT. Right, so you know that tunneling encryption is usually used by VPN, right? And the tunneling encryption hides the IP address. So if it's encrypted, NAT cannot really see the inside, right? Because it's encrypted. So this one also present a problem for NAT. Okay. All right. So I just finished this first, and then we can go for a break. Right. Now it's 3 o'clock. Right. So I just finished this first, and then we finish this section. We go for a quick break later. Right, so application layer troubleshooting. Now we have gone to transport layer. Now we go to application layer troubleshooting. At application layer troubleshooting, because application layer is actually involved with application layer protocols. So you have to familiarize yourself with all the application that uses all these protocols. So in fact, SSH, Telnet, HTTP, FTP, you need to know what they're used for. SSH Telnet is remote connections. So you can, as if you're at the terminal, you're connected to the particular device, and you can actually issue command line commands. Okay, at the operates as a remote terminal. You need a remote capable terminal like PuTTY and other terminal emulator, right? Okay, so you need to familiarize yourself with that so you can troubleshoot those kind of problems, right? HTTP is for browser, right? So FTP is for file transfer protocol. FTP client connects to FTP server, so you need to check the FTP client connectivity to the FTP server. And FTP client needs authentication, yeah. So maybe the not authenticated cannot connect to FTP server. TFTP works inside LAN, is trivial, so that means it's not using TCP, so it's using UDP. So basically, you trust that the local area network is stable enough, so there's no corruption, so you don't really need TCP. So in LAN, you prefer TFTP because you want higher transfer speed. Okay, and then SMTP is for sending email messages, okay, from your email client to your email server, right? So you need to know the specific port, right, and whether the server has an entry for your particular user, okay, your email user. POP is for retrieving. Okay, post office protocol is for retrieving email from your inbox down to your email client. Okay, SNMP for simple network management protocol. Again, SNMP can have a client, and the server can retrieve from the client's MIB some info that you want to get from that particular client. So basically monitoring, monitoring all your SNMP client to check whether they are what is their performance level. There's also you can set traps at the client side to trigger a certain message if the trigger, depending on what the trigger is, you can specify what is a trigger, what is the trap, okay, captured, right? So send you alert at the SNMP server. And then DNS is domain name service, all right? So it resolve domain name into IP address. Okay, so if a particular domain name does not have an entry inside the DNS, then it cannot resolve. So you cannot connect unless you know the IP address of that particular server. Right? Instead of typing the domain name, you have to type in the IP address. Okay. Sometimes DNS filtered or censored. Okay, so it doesn't have all the entries. Okay, huh? So NFS is a network file system, enable you to, let's say you have a NAS, network attached storage, okay, somewhere in your network. In order for you to use that drive, that storage, you need to mount, okay, of course you need to have permission, right? You have to mount that as one of your drive, okay, so that your OS can use that storage. That means then you can access it as if it's a local drive. Okay. All right. So any question? Any
Nope.
So far, no question.
Okay. All right. So there's just a few slides left. So we go for a quick break, about 10 minutes break before we continue, and then we do the after that we do the um, tutorial. All right. So let's go for a 10 minutes break.
Okay.
Mm. Hello everyone, welcome back. Right, so let's have a look at the next section, which is 12.5, troubleshooting IP connectivity. So IP connectivity can be tested as usual when we're doing the practical using the ping, right? But in addition to that, we can also use traceroute. Okay, traceroute allow us to check all the hops between source and destination. It will basically list out all the hops in between the source and destination, source and destination host. At the same time, give us the the written reply from each of the uh, hops lah, the router, right? So let's have a look at here. Um, when there is no end-to-end connectivity, we'll start with a bottom-up approach steps. That means we start from the physical layer and going all the way up to the application layer. And at each layer, we'll do the troubleshooting like what we have looked at in the previous section. Right, so because we're bottom up, so we try to see the physical layer first. We check all the physical connectivity at the point where the network communication stops. That means we want to see whether the further network connectivity is stops because there's a connection problem lah. That means physical connection problems. Maybe disconnection, right? Disconnection of the cable, or the interface itself is shut down, right? Or maybe the next hop after that hop, basically there's a failure lah. That means it's um, offline or something like that, right? And then you can check for duplex mismatch, right? In terms of duplex, it means whether you're operating at the half duplex or full duplex, right? And then check your data link and network layer. Data link layer addressing is the MAC address, and network layer addressing is your IP address. Okay, so you have to check the addressing is correct, right? And then you need to see whether your way out of your LAN, the address is correct. So you check your default gateway. This default gateway, you basically need to configure at the host part. So you go to the host and check the NIC configuration, check whether the default gateway address is provided. And if it is, then you have to check whether the default gateway address is correct. Okay. All right. So then you need to check the end-to-end connectivity, right? So you need to check that for the LAN, the switch is forwarding the frame. Okay. And for the wide area network, the router is forwarding the packets, right? And then you need to follow end-to-end, source to destination. All right. If part of the path is actually going into ISP, so as long as you are concerned, you will stop at the ISP part lah. So for the ISP, normally you can inquire with your ISP whether at their end there is any problem or not lah, because you can't trace anymore beyond the ISP. All right, but if your connection is via lease line, so it's a direct connection from your branch to another branch or branch to HQ, where you can do testing, okay, for the path from source to destination, then you may do so lah, right? And then you can also verify the transport layer is functioning properly. Transport layer, you can check for TCP, UDP, and also the port. Okay, so that means you can check the port number is accurate or not. And then at 7, you check whether your access control list is set correctly. The entries are all correct, yeah, because improper ACL entries can block traffic, right? And then finally, you can ensure whether your resolution of your domain name to the correct IP address is satisfied lah. That means these are the DNS settings, right? So sometimes if the DNS do not have the N3, okay, then you may not be able to get the IP address because there's simply no entry in there. And why there is no entry there? It could be that it's a decision of the ISP, right? Okay. Ensure that DNS settings are correct. Okay, so let's see. Usually what initiate a troubleshooting effort is discovery that you have end-to-end problem in connectivity. End-to-end simply means from source host to destination host. Okay, so you can, there are two tools that you can use. Ping, you can ping direct to the destination first, right? So ping, let's say you want to access server, so you can ping PC1 to server, right? And if there's no reply, you can then ping, you can use ping before you try to trace route, ping to your own gateway, right? And then to your your router interface facing outside network, right? So the other routers actually, you can use ping, but you can actually use traceroute better because traceroute will stop at every hop between the source and destination and report back for every hop. Okay, so if traceroute is stuck at any of the hops, then you know the problem is at which particular hop or router, right? Okay, so that is one of sorry, two of the tools that you can use. Right. So step one, verify the physical layer. Then here you can basically go to the router and type show interfaces and what interface you want to check, right? It's probably when you do that, you want to see whether it's up or down first lah, the status of the interface. Sometimes the most common is that you forgot to no shutdown lah, right? Or input queue drops, output queue drops, input error, output error, right? So this indicates there's a problem uh, with the incoming frames or incoming packets. Okay, then step two, check for duplex mismatch. So duplex mismatch in most new network shouldn't be a problem anymore because most of the newer devices and ICs, all their ports are basically duplex already. Okay, only if you are still mixing your equipment or your device with the older type of switches or hosts where the NICs running at the half duplex. Okay, and then you will find problems in terms of duplex mismatch lah. Right? So I guess this one, yes, if you know you have older machines, older devices with the older ports where it's still using half duplex, then yeah lah, you can check this. But mostly nowadays, if you buy new devices, new NIC, new computers, normally they are running at full duplex, no longer half duplex, right? Then you check the addressing on local networks, okay, by checking your ARP table. Okay, ARP table, you just type ARP-A all. It'll check you the mapping between IP address and the MAC address, right? Then you check VLAN if you configured VLAN in your local area network, you are using VLAN. Then check your VLAN's configuration, right? For example, here there's an error, the highlighted one. So you can see the MAC address on F1 should be in the VLAN 10. So this one should be VLAN 10 instead of VLAN 1. So a simple change, right? Go to that particular interface, change it to be VLAN 10, then suddenly it's part of the VLAN, then it can operate, right? Verify your default gateway. Okay, this also can be configured at the PC. So make sure your PC's default gateway address is the address of the interface on the router that's facing the network, right? Okay. Basically, sometimes as this one is you forgot to set the default gateway, or you make a typo, whether at the PC side or at the router side. Right. So same thing for IP version 6. You can also check for default gateway. Okay. Similar kind of issues can happen. Verify correct path. So you're basically going from source to destination, right? So this diagram here shows routing table information for for both IP version 4 and IP version 6, right? So process forwarding the IP version 4 and IP version 6 packet is based on, remember, this longest bit match or longest prefix match. Okay, so it will try to search for that particular destination IP address, okay, to match against any entry that can match it inside its routing table. Okay, it will be looking for the greatest or longest match of the leftmost matching bits. Okay, so the number of matching bits indicated by prefix length of the root. Yeah. So is there a match in routing table? No. Is there a default route? No. Discard packet. If there's a default route, yes, forward packet. Match in routing table, yes. Match with more than one entry, yes. All entries have the same prefix length, yes. Then load balancing is used. Means there are a couple of maybe more than a couple, means more than one, yeah, a possible route. So it is up to the router to do load balancing, which interface it can forward to. If no, not this, they don't have the same prefix length but match the more than an entry, then choose the longest matching prefix length. Okay, to forward through. Okay, this is the logic of the routers matching up with the routing table and forwarding. This is forwarding logic lah, right? Step 6, you can verify the transport layer. Okay, so transport layer, you have to check your ACL. Okay, very common because ACL, it works, and in terms of like for me, it's like a Venn diagram, right? Your options that you put in the entry can affect the next entry, can affect the next entry. So it's very easy to make a mistake in the formulation of the ACL entry. So check your ACL whether it's correct or not. Check also your NAT configuration, right? NAT configuration is basically the pool of available IP address that you can map to, right? To map to the global IP address. Yeah, it's a mapping of private and to the global IP address. Okay, so if instead of ping, if you want to test transport layer, you use telnet, right? So you try to telnet. As you can see here, example, administrator attempts to telnet to router 2 using port 80. All right. So that request, port 80 is basically expecting HTTP, but telnet is not HTTP. So you try to connect to port 80, then there's a problem lah. Then you can test telnet to connect to its port, telnet port, see whether it can connect or not. So you can verify port level transport layer lah. Okay, verifying ACLs. Because ACL, incorrect entry of ACL can block Okay, can block traffic basically, right? And also you have the possibility of entering the ACL for inbound or outbound direction. Okay, so for example, in this example, ACL 100, you can see, 100 is configured inbound on G 000 instead of inbound on S000. That means it's been put on the wrong interface. So all you need to do now is when you find out that this is the problem, is just to remove the ACL from the wrong interface and put it on the correct interface. Step 8, verify your DNS. Okay, so DNS is domain name service. You can resolve domain name to IP address. So basically, help the user from their browser. They cannot remember IP address. They type the domain name. So the browser will contact the DNS server, right? And the DNS server entry is entered into the NIC configuration along with the gateway address, right? So the the browser contacts the DNS, asks the DNS to resolve the IP address for the particular domain name. DNS search through its DNS entries, found the match, sends back the reply to the browser with the IP address. So then the browser can then complete the network layer header, okay, the destination IP address. Okay, and but verify that your DNS is actually working, right? Sometimes DNS, very hard to say that the open DNS is down, but if it is your own DNS server, it can be down, especially if you don't specify secondary DNS address is open DNS. Any of the open DNS like Google or open DNS itself, the name, yeah, right? So it could be that your DNS server is down or DNS server is not running, then fails to look up. So that means your network doesn't work in terms of all the application that use it, especially browser. All right. Okay. All right. So that's the end of this section. Any question? Any question on that part? This network troubleshooting part?
No.
No.
No, huh? All right. So I put in I've shared the tutorial 11 already. Okay, but it's a combination of additional for next week lecture also. So some part maybe not. You don't have to answer first, right? But yes, you do have to answer for some of it, right? Those are already covered. Not covered yet. Maybe answer next week lah. Right. So one thing I want to mention is later 6 p.m. I want to do a dry run. Are you guys okay with a dry run at 6 p.m. later?
Okay.
Okay.
Yeah. Okay. So because you guys are G1, so G2 RSD also will be having this week SBA as well. Okay, for BMIT 2164, they will have their SBA this week as well. You guys will have your 3094 SBA. So I'm gonna hold the SBA and this dry run at the same time. Okay, so recall that you guys will have your SBA on Wednesday, whereas the G2 will have the SBA tomorrow. Okay, so I just combine lah, right? But you can get your dry run files information from your own Google Classroom. Yeah, 3094 Google Classroom. They will get their information from their 2164 Google Classroom. So that means we all use our own Google Classroom for the dry run files, but we use the same Nic. Is that okay?
Okay.
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 Yeah, so that we can combine and then do the dry run together, because it's both as SPA, but you get your files differently lah. You guys from your own Google Classroom, they got from their own Google Classroom, right? So I'm gonna start our dry run at 6 p.m. I will share later information about the dry run in our RSC group, and also from your own individual Google Classroom. Okay, so we'll start at 6 p.m. I think it should run basically an hour or less than an hour, about an hour lah. Just prepare for an hour. Okay, right. So I want to advise you guys the same as I advise G2, that to prepare for SBA, you need to prepare the commands. Okay. In fact, our CC, actually, this is also her advice, right? You don't have time to basically search for the commands during SBA. Okay. And how do you know what commands? Okay. Our coverage for SBA, you know already, we have done the configuration inside our packet tracer, right? And the commands actually are available both from our slides and also from the NetCat website, right? So prepare all the commands that is required. Okay. For example, to set up standard ACL, name ACL, extended ACL, what are the commands, right? So that you basically just pick from all the all the commands already, put it into Notepad, then customize it, and then you can just copy and paste into either switch or router to configure it. My advice is that you inside the Notepad, you say, oh, let's say you have 2 switch to configure. Okay, that includes the basic configuration. So from your collection, get the basic configuration, get whatever else configuration, put it into the Notepad, the heading S1. Okay, of course you don't copy the S1. Let's say S1 is called, right? You can name it whatever host name that the question will ask. Then you customize it there, right? Customize it based on the question, right? And once you're confident, okay, these are all the settings I need to do for switch, the first switch 1, for example, right? And then you do the switch 2, and then you do router 1. All this in the Notepad. Once you're done, of course you save it all the time, right? You copy paste into the packet tracer, the command line interface, and then it will just execute all at once, right? If you made a mistake or you miss a configuration when you're testing it, right, you can always go back to your Notepad and check, what did I miss? Because the command is there, right? Okay, so then you can simply go back and add in, or you can just modify or change or add an entry that is missing, right? Of course, you put it in there, right? This is also safer, isn't it? Because you save in the Notepad, you keep on saving your Notepad answer, so you have a separate answer, right? In Notepad, easier for you to check also your answer, right? And to make this work, you must prepare. Okay, all of you must prepare all the commands that you think is required to you done in the and do as I said before, right? Using this method, at least you got a chance to complete, right, within the allocated time. Okay, if you don't do this, if you only doing SBA, then you trying to search for the information, what commands, definitely I can tell you you will not be able to finish the SBA. Okay, because you spend time to look for the configuration. Okay, rather before SBA, you prepare all the configuration commands, right? Okay, of course you need to know how to use it, so now to customize it based on the question, right? Is that do you agree? Noel, Farah, and Kelvin?
Yeah.
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 Please do. Please prepare so that you know you don't waste time to search for the info during SBA. You already prepared. Okay. Now your guys are lucky. Okay. Now it's still online, and you are doing packet tracer. Okay. In the maybe I don't know, in the receipt or in the coming future, it will be face to face. You have no choice, but you have to use the hardware. All right, the configuration of hardware, not much difference lah, but it brings with it a different set of problem lah, right? You know, hardware sometimes you need time to plug in all this, right? It's not as straightforward lah. So what we want is we want to pass our SPA lah, basically. So you don't have to resit. Okay. All right. So that's a preparation for your SBA on Wednesday. Right. So later on, we will have SBA dry run. All right. So as you can see, tutorial 11. Yes, I think some of it maybe you can answer already. Some of it not yet, like virtualization. I think 6 and above, like virtualization, hypervisors, not yet covered. It's going to be covered next week. So up to question number 5 should be okay to answer for your tutorial. All right. Any question, everyone?
No.
No.
Okay. All right. So I'll let you guys do lah. Okay. So we only have about 10 minutes left, but you know, you can try to do. If not complete by then, you can do as homework lah. All right. So tomorrow we have practical, right?
Yes.
Yeah. Okay. So to maybe tonight you do a little bit of your preparation. Tomorrow maybe you can show to me. Okay. Your all the commands you prepare. Okay. During the practical lah. All right. So I want to see so that maybe you guys can show me how you organize your what lah, your sort of the prepare the commands, right? So this is online SBA test and it's open book. So in fact, our CC already said can and us encourage to prepare lah. So maybe I can see tomorrow you can show me, all right, and then hopefully lah that will help you to prepare for the SBA on Wednesday. Hello, everyone. All right, so I'll see you at the 6 p.m. All right.
Okay, thank you, sir.
All right. I'll see you guys later. I'll share
Okay.
the meet link later. Yeah.